Now, we already know that histograms give us a lot of information, and it turns out they also allow us to relate the mean and the median to each other. So what we're going to be looking at is different examples of histograms, figuring out where the mean is and the median, and relating skew to the relationship between the two of these. Our first example here is going to have to do with the number of fingers people have in total. We're including thumbs. I know, some people say we shouldn't, but we're going to for this example. Now, looking at my horizontal number line here, I'm running from 0 up to 10, and first question is, where do you think the highest bar is? That is, what's the most frequent of these? 0, 1, 2, so forth. And I think we can agree that the most common measurement is people having 10 fingers and toes. So I'll go ahead and put the highest bar at 10. Now, 10 isn't the maximum numbers of fingers you can have, right? Some people have 11, some might have 12. And as we go from 10 across, that is 10 to 11, 11 to 12, and so forth, these are probably less and less and less likely. So when we add in the bars, they'll be getting smaller and smaller and smaller. Question is, how high should we go with it? And as of right now, the most fingers that someone has is actually 14. And because that's just one person, that bar is so small we can't actually see it. Okay, so we've accounted for the fact that the majority of people have 10, and some people might have 11, 12, 13, or 14 fingers. Let's go the other direction. That is, we need to ask ourselves, how likely is it for someone to have 9 fingers? And it turns out there's probably quite a few people, right, who have lost a finger or maybe born without one. So we need to put a bar at 9 that is significantly fewer than those with 10, but still, there's a number of people with that. Now, keep in mind here that these are not exact figures, right? We're just trying to get a general idea of what the shape might be. So I've got quite a few people with 9, and moving over 8, well, there's probably fewer people with 8 fingers than 9, so I'll make that bar a little smaller. And 7, still smaller still. And 6, smaller again. And then we hit 5, and if we think about this here, the likelihood that someone has 4 fingers missing, as they're only born with 6, or maybe they've lost 4, compared to the likelihood someone has 5 fingers, well, there's probably more people with 5 fingers than 6, right? Because 5 fingers would be like losing an entire hand or being born without an entire hand. So the bar for 5, we're actually going to put a little bit taller. Now, emphasizing again, that these are approximate. This is just kind of how we feel about it. 4 will probably be less than 5, 3 less, 2 less, and 1 less. So adding in those bars, we come to 0. And here's the thing. Think about having 1 finger versus having no fingers. Probably more likely that people are missing both hands, right? Either they're born without them or they're missing both of them now. And so the bar for 0 is actually going to be taller than the bar for 1. And reinforcing again that these are approximate values here, let's go ahead and look at the shape we have for it. What I want you to notice is that my highest bar is at 10, but in reality, this graph here, this histogram, is not unimodal, right? I actually have 3 peaks. I have a peak here at 0, 1 at 5, and 1 at 10. This is trimodal, but remember we don't tend to use that language. We would call this multimodal. As well as multimodal, if I go ahead and outline the shape of it, I get this little tail here, and up, and so forth. Now, this shape right here, looking at it without the bars, based on this overlay then, I can tell that my data definitely has a left skew to it. That is, well, it looks like the majority of people have 10 fingers. There's a lot of people below that, which is pulling my drawing here to the left. Now, based off of what we know and our histogram, it's pretty safe to assume that the median is 10 fingers. That is, that if we look at the lower and upper half, the dividing point for those is 10 fingers, right? The majority of people actually have that. So, the median for this data set would be 10. The question is, what about the mean? Remember, the mean is calculated by adding up all my observations and dividing by the number of people. And I can see, based on my histogram, that I'm going to be adding in 0s, 2s, 1s, 3s, 4s, 5s, 6s, and 7s, 8s, and 9s, a lot more than any of the numbers over here. So when I add these all up and divide them, my mean, while I don't know exactly what it's going to be, is probably going to be less than 10. And that's because these lower numbers here are going to pull that mean down. That is, my mean will be somewhere over here, while my median will be right here. And what this shows us is my mean is going to be less than my median in this case. And that's because those numbers over on that left side are dragging the mean down. That is, my mean is going to be less than my median anytime I have a left skew.